In this video, we're going to be taking a look at predicting outcomes. And in case you're wondering what this is right here, that is actually a crystal ball. So we're going to be looking into our crystal ball today and predicting some outcomes of certain events. Now the goal for today is that we're going to be identifying events and favorable outcomes and determine if an outcome is equally likely. In other words, if they all have equal chance of coming out a certain way. Impossible, in other words, it could never happen. Less likely, more likely, or certain. Okay, we're going to take a look at a few terms and events and things like that together. You want to get out your notes. You're going to write some of these things down. So first of all, we're going to take a look at the question, what outcomes are likely? Now, for example, we're going to take a look at our number cube, just a regular number cube that you would use to play any type of game. Now, if you were to toss a number cube, the outcomes are 1, 2, 3, 4, 5, and 6. Those are the different outcomes that are possible. Okay, now each outcome is equally likely, and the reason why it's equally likely because there's just 1 out of 6 chances for the 1 to be rolled, the 2 to be rolled, and so on. There's not a certain number that occurs more than once. They all occur the same time on the number cube. So that is an equally likely event. Okay, I'm sorry, equally likely outcome for each number that will be rolled. Okay, now an event is a collection of one or more outcomes. So I want you to write these certain terms down in your notes, and we're going to take a look at some examples here. Now let's take a look at example A there on the left screen. It says compare the chances of tossing an even number and tossing an odd number. Okay, so the event would be tossing an even number. Favorable outcomes would be 2, 4, and 6. And the reason why it's favorable is because that's what we're trying to do. That's why it's called favorable. Now 3 out of 6 possible outcomes are favorable. So in 3 out of 6 tosses, you can expect an even number. Now it may not occur this way. If you just do it 6 times, for example, it may not occur 3 out of 6 times. However, the more tosses that you do, the more likely you'll have more of an even outcome. It may not always work like this though. Okay, so let's say we have an event of tossing an odd number. Favorable outcomes, in other words, the outcomes that we would like would be 1, 3, and 5. 3 of 6 possible outcomes are favorable. So that means in 3 out of 6 tosses you can expect an odd number. Okay, so as far as likely, equally likely, and so on, tossing an even number and tossing an odd number are both equally likely events because both events have 3 out of 6 for the favorable outcome. Now if we were to say what's the possibility of tossing a 0, that would be impossible because there's not a 0 at all on the number cube. Or if we were to say what's the possibility of tossing a 1, 2, 3, 4, 5, 6 or an odd or even number, that would be certain because every single number on the number cube is either odd or even. Now let's take a look at example B. It says compare the chances of tossing the number 6 or tossing a number less than 6. So the event that we want to do would be tossing the number 6. Favorable outcome, in other words, the outcome we want to try to attain is the number 6. So one of the 6 possible outcomes is favorable. So in 1 out of 6 tosses, you can expect the number 6. Okay, now we have another event, tossing a number less than 6. Favorable outcomes 1, 2, 3, 4, and 5. So 5 out of 6 possible outcomes are favorable. So in 5 out of 6 tosses, you can expect a 1, 2, 3, 4, or 5. Now gathering all this information is important, and then we want to think about, is it likely, equally likely, and so on. So tossing a 6 is less likely than tossing a number less than 6. Pretty much common sense here because we have the number 6. There's only one 6. However, there's 5 other digits on the number cube that are less than 6. So tossing a 6 is less likely. Does not mean it will never happen. It's just less likely. However, tossing a number that is 6 is more likely than tossing tossing a number less than 6 is more likely than tossing a 6. Okay, because we have 5 chances compared to 1. So 5 out of 6 possibilities could be tossing a number less than 6. 1 out of 6 possibilities for the number 6. So tossing the number 6 is less likely. Tossing a number that is less than 6 is more likely. Now I want you to get out your notes, and we're going to work through these problems together. So taking a look at number 1, and we're going to take a look at spinner A, which is right here. Spinner on the left. Okay, so it says, what are the possible outcome colors? So what we do, we just simply take a look at the possible outcome colors, which would be red, green, blue, and yellow. Now, we want to, so that's our information we're starting to collect. Are the colors equally likely? In other words, if you were to spin the spinner, is it equally likely we would land on all of the colors? Okay, and that answer is yes, they are all equally likely. The reason why we know that is because, first of all, the sections are of equal size. Okay, then also each color just occurs one time, and that's it. If we had yellow occurring more than once, they would not be equally likely. However, they're all just occurring one time, so they would all be equally likely. Now, the question, in 100 spins, how many times would you expect spinner A to land on red? Okay, and we could pretty much expect the spinner A to land on red about 25 times. And the reason why, if you take 100 and divide it by 4, it's 25. So if each section has an equally likely chance, it's a possibility that 25 out of 100 spins would land on a certain color. It will not necessarily be exact if you were to do this procedure. Okay, however, it would give you that chance. It's a prediction. Okay, now if we're taking a look at spinner B, they're asking the question, how many different outcomes are possible? Okay, what we could say for this, there are actually 3 outcomes that are possible, because you can have the red occurs twice, then we have green, and then blue. So just 3 outcomes or 3 different colors. Now the question, are the colors equally likely to occur? And the answer to that question is no. Okay, and the reason why it's no is there are twice as many red sections as any other color sections. Okay, so you can see it's more likely that we land on red. It's less likely that we'll land on green or blue. However, it's impossible to land on the color pink, for example, because it's not even there. All right. Now, question number 4, what color would you expect to occur most often? That would be red. Now here's another question, kind of like question 2 at the top. In 100 spins, how many times would you expect spinner B to land on red? Okay, and we could say that we could expect spinner B to land on red about 50 times. Okay, because that's 2 out of 4 chances are red. Okay, so half the spins would most likely land on red. May not be exact, okay, but we could say that in 100 spins, about 50 times should land on red, and it's most likely that it would be a greater number than any of the other colors. So let's take a look at some more examples. Okay, now we have the scenario at the top. It says, think of putting 5 red counters, 2 blue counters, and 1 yellow counter in a bag. Then think of drawing 1 counter at a time and then replacing it after each draw. Okay, so taking a look at number 6, it says, consider the events draw red, draw blue, and draw yellow. Are the events equally likely? And the answer to that question is no. Okay, and the reason why we know they're not equally likely, because they do not have the same amount of counters in the bag. We could see that the red has the most, then the blue, then the yellow. Question number 7. Which event is most likely? Which event is least likely? What I want you to do is pause the video, write the answer down in your notebook, and then you can press play and I'll have the answer for you. So pause the video now. Okay, the answer for number 7, which event is most likely, pretty obvious here, draw red. Least likely would be draw yellow, and the reason why we know that is because there are 5 red counters and 1 yellow counter. Now let's take a look at number 8 together. It says if you drew a counter 80 times, how many times would you expect to draw a red counter, a blue counter, and a yellow counter? And it says, hint, think about how many would be expected for each color if only 8 counters were drawn, then multiply each number by 8. Okay, so for example, we could see that there are 8 total counters, so the fraction for the red counters would be 5 out of 8. Blue counters 2 out of 8, and then the yellow counters 1 out of 8 for my fractions here. Okay, so we could see that we want to multiply each outcome by 10. Okay, so if you drew 80 times, how many red counters would we draw? We would say 50 red counters, 50 out of 80. Blue counters, we would say 20 out of 80. And then finally, the yellow counters would be 10 out of 80. Okay, so 50, 20, 10 all do equal 80, so that would answer the question number 8. And now I want you to pause the video and I want you to answer questions number 9, 10, 11, and 12. And when you press play, I will have the answers for you. So pause the video now. Now taking a look at number 9, I alluded to this throughout the video. Okay, it says if you actually perform an experiment with the counters described above, do you think the results of your experiment would be the same as the expected results in question 8? And actually the answer to that would be no. Okay, expected results or predicting outcomes and experimental results often are different. Okay, so it would not necessarily match that exactly. It should be pretty close, but it will not match it exactly. Now, number 10 says, describe an event about drawing a counter that is impossible. Okay, so you just need to say something, for example, drawing a green counter or drawing a counter that's not even in the bag. Those are color that's not even in the bag. Those would represent impossible events. Describe an event about drawing a counter that is certain. You may say something like drawing a primary color, or maybe drawing a red, blue, or yellow. That would be a certain event. In other words, no matter what happens, no matter what the weather would be like outside, for example, you would just always draw a certain color there. Now explain why some events are more likely than others. Well, we could say for number 12, events that have more favorable outcomes and the possible outcomes are more likely to occur. Okay, for example, just think about it. The larger the amount, the greater the amount of counters, the more likely the event will happen. The less amount of counters you have, the least likely the event will happen. Okay, so this concludes our video in predicting outcomes. If you have any questions, please come and see me.